Hello everyone, good day. So today we'll be discussing degree of indeterminacy. So this topic is under theory of structure. Okay. So what are the formulas for us to identify the degree of indeterminacy of a certain structure? And okay, so we have for beams, we have R minus 3 minus C. For frame, we have R plus 3M minus 3J minus C. And for trusses, we have R plus M minus T 2J. So R here is the number of external reactions, the number of the unknown on of the supports. M 3 is constant, and then C is special conditions. Or this is the number of releases or the equation of condition. Again, the formula is R minus 3 minus C. We are very familiar with the number of reactions or the unknown reactions. However, uh, what is letter C here or the number of conditions? So we only have three special conditions. We have to be familiarized. Okay? So first is an internal hinge. Okay? So pag nakakita kayo ng internal hinge, okay, take note yung moment dyan sa internal hinge is equal to 0, meaning na-release yung moment. So, special conditions is the number of release. So, therefore, kung ilan yung release dito, which is moment, wala siyang moment, C dyan is equal to 1. Okay? Next is internal glide. Okay? Internal glide ang tawag dyan. Now, for internal glide, you can move this vertically. So, meaning shear is equal to 0, shear force. The number of special condition here is equal to 1. Only shear was released. Now, next is roller, internal roller. So, what are the forces being released at that internal roller? So, we have the horizontal reaction that is equal to 0. Walang axial force ito. The moment at that point is also equal to 0. Okay? And then we have two special conditions for that. Okay? So again, internal hinge, one special condition, internal glide, one special condition, internal roller, two special condition. Okay, so we're now ready to solve this sample problem. For the problem shown, determine whether the structure is unstable. When we say unstable structure, the degree of indeterminacy, again, the degree of indeterminacy for okay, a beams, we are solving here beams. So we have R minus 3 plus C. So if the value here, if the value of the degree of indeterminacy, okay, is negative, if DI is equal to a negative value, meaning it is unstable. However, if the degree of indeterminacy is equal to 0, that is stable and determinate. Now, if the value of the degree of indeterminacy is a positive, okay, value greater than 0, or the degree of indeterminacy is greater than 0. Okay, so let's say the degree of indeterminacy is greater than 0 here. The degree of indeterminacy is less than 0. And if the degree of indeterminacy is greater than 0, okay, that is still stable and indeterminate. Indeterminate. Okay? So, let's say for this problem, we will identify the degree of indeterminacy. So, this is a fixed support. Let's count the number of reactions for a fixed support. For the number of reactions, we have vertical reaction, we have horizontal reaction, and then a moment. So, three unknowns reaction. For the right support, so this is also a fixed support. So we have vertical reaction, horizontal reaction, and a moment. Okay? So meaning how many number of reactions. The degree of indeterminacy, this is your formula. So 6 reactions minus 3, a fixed number, and C. This is an internal hinge. So which gives you C is equal to 1. Okay? So plus, so this is plus 1. Therefore, the degree of indeterminacy is equal to, this is 3 plus 1. So that is equal to, or 6, no? 6, this is 3 plus, this is equal to 4. Okay? R minus 3 plus C. Or, tama. Sorry. It should be minus, not plus. Sorry. It should be minus. Okay. Minus. Okay. Just to be clear, it should be minus. Okay. So, minus. R minus 3 minus C. Okay. So, therefore, it is 2. Yeah. Now, for this problem, let's identify, meaning degree of indeterminacy is equal to 2. So, that is stable, or we can just simply say indeterminate to the second degree. Okay? Indeterminate to second degree. Okay? Now for this problem, let's count the number of reactions. So 1, 2, this is a fixed support. So 3, a moment. Again, you have vertical reaction, horizontal reaction, and then a moment. Take note, a fixed support contains a moment. Okay? So this is vertical, horizontal, and a moment reaction. So this is a fixed support again. We have horizontal reaction, a vertical reaction, and a moment. This is a roller support. You only have one reaction, vertical. Roller support, you only have one reaction. So you have many reactions. So the degree of indeterminacy for this structure is equal to 6. 3 plus 3, 6, 7, 8 reactions minus a fixed number 3 minus number of special conditions. This is an internal hinge, so C is equal to, okay, 1. This is an internal glide, so C is equal to 1. So again, these are your guide for the number of special conditions. So minus, so the number of C here is 2. Therefore, the degree of indeterminacy is equal to 3, or indeterminate to the third degree. Indeterminate third degree. Okay. Next, for this problem, okay, so let's identify the degree of indeterminacy. Let's count the number of reactions. For this hinge, we have 2 reactions. And then for this fixed support, we have 3 reactions, horizontal, vertical, and a moment. Okay. So the number of reactions is, okay, the number of reactions is 5. This is not a rope support. This is an internal roller. Take note of that. Okay, this is an internal roller. Okay, for internal roller, so internal roller. For internal roller, C is equal to 2. Take note of that. C is equal to 2. So therefore, so from the formula, degree of indeterminacy 5 minus 3 minus 2. So this figure is equal to 0, or simply say statically determinate. Okay. So what if for this problem, we are going to convert that into a roller support. Okay, so roller support, and this is a fix. So what will happen to the answer? So the degree of indeterminacy is equal to how many reactions for this problem? So for the reactions, it will be only four reactions. One for a roller, three for a hinge, for a fixed support. Okay, then minus 3, a fixed number, minus 2 for internal roller. So therefore, your answer here for the degree of indeterminacy is equal to negative 1, and a negative value is unstable. Why is it this figure is unstable? Actually, you can observe this. Okay, when you say unstable structure, as you try to apply a load, okay, try to apply a load in any direction, it will move. Okay? Let's say you try to apply a load here, it will move horizontally. Okay, so that's why this structure is unstable. Okay? However, if you are going to put here a hinge support, 'di ba ang hinge may horizontal reaction dito? So therefore, it will not move even you apply a force here. Take note lang sa structure must be stable. If that is unstable, gagalaw yun. So all structure must be stable. And in this case, negative ang degree of indeterminacy, so that is unstable. Okay? Again, just a recall, okay, if the degree of indeterminacy is less than 0, unstable. 0, stable and determinate, statically determinate. And for greater than 0, that is indeterminate. So that is for the degree of indeterminacy of the beams. Okay, now how about for okay, truss? For trusses, this is your formula. Okay, so the degree of indeterminacy for trusses is okay, this one. R plus 3M minus 3J minus C. So what is M? M is the number of member. Okay, J is the number of joint. C, sorry, this is for truss. Wala, sorry. R plus M minus 2J. R is the number of reactions of the supports, rather, number of the unknown reactions of the supports. M is the number of members, and minus 2J. Okay, let's try to solve sample problems of trusses. Okay, so for this problem, let's count the number of the reactions at the supports. For the reactions, for roller, we have 1. For hinge, we have 1, 2. The formula for the degree of indeterminacy for trusses, so di is equal to r plus the number of member minus 2 times the number of joints. So member, bilangin natin kung ilan yung number of members. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 number of members. Okay, so let's calculate the degree of indeterminacy. Di is equal to reactions. We have 3 reactions. For roller, 1 reaction. For hinge, 2 reactions. For the number of member, again, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 number of reactions. For the number of joints, 2 times the number of joints. So let's calculate the number of joints or the number of connections. Okay, this one is also a joint, including the point of support. Joint number 1, 2, 3, 4, 5, 6, 7, and then 8 joints. We have a total of 8 joints. Okay, so therefore, for the degree of indeterminacy, so that is equal to, okay, so that is 16 and then 16, 0, or statically determinate. Okay, now next problem. Okay, so the degree of indeterminacy is equal to, count the number of reactions at the support. So we have hinge here, 2 reactions. For roller, 1 reaction. Okay, for the degree of indeterminacy, okay, so we have 3. Okay, 3 for the reactions plus the number of member. Let's count the number of member. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Number of members. Take note, class, we only count this member as one. This one. Okay, one member and another member. Okay, we do not count this as 4 member, 1, 2, 3, 4, because we don't have any joint here. Now, member can be classified end to end. A member should have a joint end to end. So, therefore, isang member lang to, class. Okay? You should not count this as a 2 members or 1, 2. Okay? It should be 1 member. But if you are going to put here a hinge, you can call that this is 2. You can say that this is 2 member. Okay? Again, you only have 14 members for this uh truss. Now let's count the number of joint. For the number of joint, we have 1, 2, 3, 4, 5, 6, 7, and 8. Again, we don't have any joint at this point. Tawag dyan, class, is cross bracing. Okay? So, minus 2 times 8. So, therefore, the answer is equal to, okay, a positive 1. So, this is indeterminate to the first degree. To the first degree. Okay? Next, okay, last one. For the degree of indeterminacy for this problem, the degree of indeterminacy is equal to how many number of reactions do we have here? So 1, okay, 2, 3, and 4, 5, okay, 6. So we have 6 number, 1, 2, 3, 4, 5, 6 number of reactions. Okay, next, the number of members. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we have 11 number of members plus 11 minus 2 times the number of the joints. So for the joints, we have 1, 2, 3, 4, 5, and 6 number of joints. 2 times 6. Okay, answer here is 12. So you have 6. Okay, so this is 17. 17 minus 12, this is 5. Okay, so this is statically indeterminate to the first degree. So this is your answer for these 3 problems. Okay, so next is degree of indeterminacy for frames. Okay, for the structure shown below, identify whether the structure is unstable, determinate, or statically indeterminate. For frame, the degree of indeterminacy is R plus. So let's just look on the table here. Trusses or frame 3M minus 3J minus C. Okay, plus 3M minus 3 times the number of joints minus C. Frame class is combination of vertical member or a column and a horizontal member or a beam. Okay, even that is an inclined member, we can still say that is a beam or column. if that is an inclined member. Okay, so this is your formula. So let's count the number of unknown for this first problem. So the degree of indeterminacy is equal to the number of reactions here for the fixed. This is fixed support. So 1, 2, and then what is next? The moment. So we have vertical, horizontal, and a moment. For this one, we have two unknowns, the horizontal and vertical. So meaning 5 okay, reactions plus the number of member. So kada yung member dito class, kada mayroong joint, okay? Or mabebend yung nagkakaroon ng bend yung member. So we can consider that one straight line is one member. We have two member here, 1, 2. Then we have two member here. Okay, so we have 1 and 2 members. So 3 times 2. How many joints? So we have this joint. The support is also a joint. 1. Okay, all support is considered as joint. So we have 1, 2, and then 3. Okay, plus or minus 3 times the number of joints. So 2 joints. Okay, next, minus the number of special conditions. Special conditions are, okay, internal hinge, internal roller, and internal glide. For this case, we have here an internal roller. We have an internal roller, okay, IR, which is ang special condition yan is equal to 1. Okay, internal pin. Okay, this is not internal roller. It is an internal pin. Okay, this is an internal pin, which is C is equal to 1. Okay, so C is equal to 1. So therefore, the degree of indeterminacy is equal to, so that is, this is 0. A number of joints, sorry, for the number of joints, 3 times 3. Okay, so number of joints, it should be 3 joints. Okay, so 1, 2, 3. 3 times 3 here. Okay, so answer is equal to, okay, so the degree of indeterminacy, we have 5 plus 3 times 2 times 2 minus 3 times 3 minus 1. So answer is 1. Statically indeterminate to the first degree. How about this problem? Okay, so we have 1. Reactions muna. The degree of indeterminacy is equal to, okay, reaction plus 3 times the number of members plus 3 times the number of joints minus rather should be minus times the number of joints, okay, minus the special condition. For this problem, we have how many number of reactions? So for this one, 1, 2 for a hinge, for a fix, 1, 2, and then a moment, 3, 1, 2, 3. For a roller, 1. Okay, how many total number of reactions? So 1, 2, 3, 6, 7, 8, 9 reactions. How many members do we have? Okay, for the number of member, we have 1, 2. Okay, this is one member, 2, 3, and 4. Every time na may connections diyan, so mahahati yan sa mga members. So 1, 2, 3, 4, 5, 6, and 7 members. 7. How many number of the joints? So including this is a joint. 1, 2, okay, 3, 4, 5, 6, 7, and 8 joints. How many number of conditions diyan? So technically, we don't have any internal hinge, internal roller, or internal glide. So the degree of indeterminacy is equal to or the number of special condition is equal to 0. So therefore, the degree of indeterminacy is equal to what? Okay, that is equal to 6. Okay. Or static and indeterminate to the 6th degree. Okay, next is um so yeah, so we have how many reactions here? The degree of indeterminacy is equal to a blank plus number of reactions 3 times the number of members, okay, minus 3 times the number of joints minus the number of special conditions. The number of reactions support this is fixed. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Okay, number of members, we have here 1, 2, 3, 4, 5, 6, 7, 8 members. Number of joints, 1, 2, 3, 4, 5, 6, 7, 8 joints minus 0 special condition. We don't have any internal hinge, internal roller, or internal glide here. So therefore, the degree of indeterminacy is equal to 9. Okay? That's how you identify the degree of indeterminacy of a frame.